Welcome to lesson 3 in our Maths 112. In our lesson 3, we shall be seeing applications of differentiation. Now, we want to learn how to apply this. So we are going to be applying this, our differentiation. We're going to apply it to kinematics. We are going to apply it to plotting of graphs. These are the two applications for now we're going to do. Okay, let's look at our case 3.1 under this lesson 3 now. Gradient of curve at a point. Gradient means slope, and slope is the y dx. So when you ask to find the gradient or have to find slope, all you need to do is to find the y dx. But one funny thing is that when you ask to find the gradient, they must give you a certain point. This point, the value in this point will help you to get your gradient as a constant, not as a function, as we have always done. So let's see some example that will drive this point home. They say if y is equals to x minus 3, x minus 2 at 1, 2. We are asked to find the gradient of this function at this point. Find the y dx of this function at this point. Find the y dx of this function at this point. That is what the question wants us to do. So at this point, what we are going to do is, I'm going to solve here, solution. I'm going to differentiate this. Looking at this now, you see that this one will be product rule. So first of all, I would like to expand. This question becomes x squared minus 2x minus 3x plus 6. So that I have x squared minus 5x plus 6. Now, seeing this question as this, I will now have my dy dx is 2x minus 5. That becomes my dy dx. Now, at x equals to, this is x, this is y, but I have only space for x there. At x equals to 1, my dy over dx becomes 2 into 1 minus 5. 2 times 1 is 2. 2 minus 5 is minus 3. And that becomes my slope, or you call it my gradient. So this is my gradient. So that is my gradient. Gradient of this function, or you call it this curve. So that is how we find slope. Now, we'll look for slope, we'll look for tangent, we'll look for normal. Then at the end of the day, we'll look for turning point, critical point, stationary point. Then before you know it, we are plotting our graph. We are sketching, but we're going to be using sketch, not the normal graph sheet here now. So I believe this question solution is well understood. Let's look at another example. Okay, look at this example 2. In example 1, we learned how to find the gradient, or you call it the slope of a curve. Now, in that example 1, again, we were given the function, or you call it the curve. We are given the coordinates, that is the value of x and y in the bracket, and we are asked to obtain the slope, which is the gradient. But in this case now, they say find the coordinates. Now, we are the one looking for the value of x and y. Find the coordinates. Let's say coordinate or coordinates, whichever way it will be, of the point on the curve. This, if the gradient is half. They've given me the gradient, they've given me the curve, but they took away how to get x and what? Y. So what I'm going to do here, solution. First of all, I'm going to find the y, the x. So I have that y is equals to 2x to the power minus 2. That should be what it's supposed to be. So my dy over dx becomes minus 4 x minus 2 minus 1 minus 3. So this becomes minus 4 over x raised to the power what? 3. So that becomes my answer. Minus 4 over x raised to the power what? 3. Now, they said that my dy dx is equals to half. My dy dx is equals to half. That means this is equals to this. Therefore, if the y over the x is equals to half, therefore, minus 4 over x cubed should be equals to 1 over 2. At this point, I'm going to what? Cross multiply. I'm going to be having x cubed is equals to minus 8. X cubed is equals to minus 8, so that x becomes cube root of 8, which is cube root of minus 8. And that will give me 2. Cube root of minus 8 is 2. So that means I've got the value for my what? X. If this is the value for my x, for me to get the value for my y, I will take the value of x and put into the question. Remember, I will say, but y is equals to 2 over x squared. So I know the value of x. So I have y to be equals to 2 over 2 raised to power 2, which will give me 2 over 4. And that produces 1 over 2. Hence, the value of my x and y, x is 2, then y is what? Half. So that is it. The question says I should find the coordinates. These are the coordinates. These are the coordinates. So I can be given the slope and asked to find, give him the curve and asked to find the coordinates. I can be given the coordinates, given this curve and asked to find the slope. So that is all that is here. Okay. We move to some other. Now, if you look at the ball in 3.2, we'll be seeing equation of tangent to a curve. If we have to find equation of tangent to a curve, what do we do there? You must know that equation of tangent. A tangent is a line, a straight line that cuts a curve at a point. Now, for me to work on equation of tangent, remember I said equation, so our answer will be an equation. First of all, you must note that equation of a straight line, since tangent is a straight line, so equation of a straight line is y is equals to mx plus c. This is equation of a straight line. Then where y is the y-axis, x is the x-axis, m is the slope, and the c is the intercept. We have learned to find the slope, or you call it the gradient. So we want to get an equation of, that will give us a curve and ask us to find the tangent to that curve. That means you form an equation of a straight line, which if they plot with that curve, it will cut that curve at a point. That is, the point will be x and y. Do you get that? So whatever equation we'll be getting, we'll be trying to put it in the format of equation of a straight line, which is y equals to mx plus c. So for me to find equation of tangent, I will be using y minus y1 over x minus x1 into what? M. This is my formula for equation of tangent to a curve. This is my equation. So when they ask me to find equation of tangent to a curve, my mind should go directly here because it's what I'm going to be using. So let's take an example to drive the point home. Example here says, find the equation of tangent to the curve y equals to x squared minus 3x plus 2 at 1, 2. We are asked to find equation of tangent to this curve. Equation of tangent to this curve at this point. So what I'm going to do first is to find my slope. Remember that we are using y minus y1 over x minus x1 equals to m, where m is my slope. And I've gotten how to get slope. I've taught us how to get slope in the first exam, in 3.1, which you also call gradient. So my y1 and x1 are what are given to me here. This is my x1, this is my y1. Remember the x comes before the y. Okay, so what I'm going to do first is to get my slope. If I can get my slope, then I'll come here and input the value of y and x, cross multiply, and I'll now get an equation that will look like this. And I call that equation of tangent, of which it means it is the equation that if you plot against this curve, it will cut it at that point x and this point what? Y. Okay? So solution, I'll be having that the y over the x becomes 2x minus 3. This is my dy dx. 2x minus 3. Then at x equals to 1, I'll have my dy over dx to be 2 into 1 minus 3, which will give me minus 1, which becomes my what? Slope. I've got my slope. M equals to minus 1. Okay? Then I'll be applying this. I'll have y minus y1, which is 2, over x minus x1, which is 1, equals to minus 1. What I'm going to do here is I'm going to cross multiply. I have y minus 2 equals to minus 1 x minus 1. See what I've done? I cross multiplied. So that I have y minus 2 equals to minus x plus 1. If I've got that, I can come up here to finish up. Let me use here. In this case now, remember we are going to make it to look like y equals to mx plus c. So I want only my y to remain here. So I have that y is equals to minus x plus 1 plus 2. So that y becomes minus x plus 1 plus 2 plus 3. This becomes the immediate equation. In this equation now, this is my y-axis, this is my x-axis. My slope is minus 1, which is correct. Then I have an intercept of what? Plus 3. So this is the equation of a straight line, which is going to be tangential to this curve. So I've obtained my equation of a what? A straight line. So that is our example 1, as simple as that. We can try, let's see example 2. Okay, let's look at example 2. You see, in this example, we have to find equation of tangent to this curve. If you look at the curve, you see that it's an implicit function. And we are going to do it at 1, 2. I'm going to use here. So, to differentiate this, remember if you differentiate y, you are going to have the y, the x attached to it. So, I'm going to be using u dv plus v du to do this. Okay, so I have x squared into the y dx plus y into 2x. I'm through with this. U dv plus v du. Then plus the same thing I'm going to use here. Y cubed into 1 plus x into 3y squared, the y dx. I've differentiated this, plus 3 equals to 0. Okay? The next thing I'm going to do is, I'm going to, if you know you are carrying the y dx, remain. If you're not carrying the y dx, go to the other side. So I have factored out the y dx. I have here to be x squared plus 3xy squared. I think that is all. This guy, then equals to minus 2yx minus y cubed, then minus 3. So that my dy over dx becomes minus 2yx minus y cubed minus 3 over x squared plus 3xy squared. Okay, having got that as my dy over dx, Then at 1, 2, we'll be having minus 2 into 1 minus 2 cube minus 3 over 1 squared plus 3 into 1 into 2 squared, I think. Okay. I pick my calculator. This is 4 minus 5. 2 times 2, 4. 4 times 2, 8. Minus 8 minus 3 over 1 plus 3. 3 times 1 is 3. 2 times 2 is 4. 4 times 3 is 12. Plus 12. So if we have there minus 5 minus 8 minus 3 divided by 13, it will give me minus 16 over 13. So here now, we have that our m is equals to minus 16 over what? 13. So the next thing I'm going to now get is the equation of tangent. I'm going to be using, I'm cleaning here. My equation of tangent becomes y minus y1 over x minus x1 equals to m. So I have y minus, my y1 is 2, x minus my x1 is 1, equals to minus 16 over 13. So at this point, I have 13 into y minus 2 equals to minus 16 into x minus 1. This will give me 13y minus 2 times 3 is 6, 2 times 1 is 2, 26, equals to minus 16x plus 16. Remember that we are looking at equation of a straight line. Okay. So I have 13y equals to minus 16x plus 16 plus 26. So that I will have 13y to be equals to 16 plus 26 is 42 minus 16x plus 42. Therefore, my y becomes minus 16x over 13 plus 42 over 13. This becomes the needed equation. Y equals to mx plus c. That means my slope is minus 16 over 13, which we have got here. Then this is the x coordinate. Then 42 over 13 becomes our what? Intercept. Our intercept. So this is equation of tangent to that curve, to this curve. So you've seen where we are given an implicit function as an equation. So you see, this is what we call application. We have learned all these things, so we are just applying it to get tangent to a curve. We have applied it to get slope of a given curve at a given point. So that will bring us to the end of equation of tangent to a curve. We move to equation of normal to a curve. Okay, we move to 3.3. This one is going to be equation of normal to a curve. Now, we've seen the equation of tangent to a curve, and we said when you're solving for equation of tangent to a curve, you're going to be using the y equals to y minus y1 over x minus x1 equals to m. But when you are talking about equation of normal, the slope you are going to be using is, let me just say that a normal is a line that is, when a normal is a straight line that is perpendicular to another line. Now, For you to say that two lines are perpendicular to each other, it means that they are, if you find the slope of this one and the slope of this one and multiply them, it will give you -1. That means M1 for this one and M2 for this one should give me -1. If this is the case, then this line is perpendicular to this line. So in that case, the slope we are going to be using is the M2 now. So I can, for normal now, it's still the same equation, but here is M2. And how do you get M2? It is y minus y1 over x minus x1 is equals to 1 over m1. That is -1 over m1. This can also be equation of normal. Equation of normal. And that's what you are saying here. M1 times M2 equals to -1. So that M2 becomes -1 over what? M1. How do you get your M1? M1 is the way you get this normal slope, or you can decide to remove this one so that you know that your M is the slope. So I know that your M is the slope. Let's start with something. Let's start with something. We have a question here that says, find the equation of normal to the curve. Find the equation of normal to the curve y equals to 1 over x at x equals to 2. Find the equation of normal to this curve at s equals to 2. The same way we have done tangent is the same way we are going to do normal. But the only difference is that getting the slope of normal is going to be -1 over the slope, not just directly the slope. So I will have that the y over the x will give me, this is same thing as y equals to x raised to power -1. Therefore, the y over the x supposed to give me -1x raised to power -2. Hope you get that. Which is the same thing as -x raised to power -2. Therefore, the y over the x becomes -1 over x squared. Okay, I've got the y, the x. Then at x equals to 2, so I have -1 over 2 all squared, which is -1 over 4. Aha. So my slope is -1 over 4. Remember here I have the x coordinate, but they didn't give me the y coordinate. So I'm going to look for the y coordinate. So if I know that my x is 2, if x is equals to 2, then y is equals to 1 over x, which is equals to 1 over 2. So my coordinates become 2, 1 over 2. You get that? So I've got my slope. This is my slope, which is my m. And then these are my coordinates. These are my coordinates, x and y. Then the next thing I'm going to do is to use this thing to get the equation. My equation becomes y minus y1 is half